See, I'm talking about, have you ever seen any acid?
Sir, vinegar maybe.
Vinegar, yeah. Which acid there is? Which acid is this? Okay. Vinegar
Okay.
contains 7% acetic acid. 7% acetic acid. Anything else you have seen as an acid?
So 11.
Lemon. Okay. Lemon juice. Right?
Yes.
Yeah.
Yes.
Which acid does it contain? It contains
Citric acid.
very good, citric acid. Anything else as an acid you have seen in your daily life, around you, at your home, in your surrounding? Have you ever seen any acid? You have
So this
seen,
orange, so the orange of the fruit, does it count as an acid?
yeah, orange juice contain citric acid. What you find here, they are all sour in taste. Yes or no? So basically, acid is a Latin word which means sour, S-O-U-R. If you taste an acid, that will be sour in taste. It will not be sweet, it will not be bitter, but that will be sour. Right? So acid word has been derived from a Latin word acidus, which means sour. Okay. Okay. Anything that is strong acid. Have you ever seen any stronger? Because the acid that you're naming are very, very, very weak. You can eat them. You can drink it. You can drink the lemon juice. You can drink the even vinegar also, right? If not drink, you can use it. Yeah. So anything, any acid that you can't consume, can't put in your mouth, can't even touch it. If you touch it, it will burn it. It will burn your skin.
Sir, phenol.
Phenol,
The phenolphthalein.
phenolphthalein.
Uh,
Okay.
So
Phenolphthalein.
hydrochloric acid.
Hydrochloric acid. Okay. Phenolphthalein is not an acid. It's an indicator. Phenol. Uh, Mavish, turn on a video, please. Mavish, shake. Yeah. So the toilet cleaner. Have you seen that? Harpic or something. If you touch it, it'll burn your hand. Right. So they all are acids. Wait, please. Okay. Have you seen any base? Base. Base is
Sir,
actually,
soap.
yeah,
Soap.
soap. Okay. Basically, bases are bitter in taste. So soap is bitter, right? Have you ever tasted?
I've
Just
tasted it one time, sir.
okay. Accidentally or deliberately?
No, it was accident.
Accidentally. Okay.
Accident.
Accidentally. Yeah, of course. Actually, what happened? These days, all the soap that we have available is in the form of the cake, right? Something cuboidal. But there is some type of special type of soap is available in the market, which is available for laundry purpose only, and that comes in small small flakes, right? The flakes were very very thin, and that was all contained in my house, and it was looking just like the uh, salty, what do you call namkeen, that we take it with the tea or something, right? Snacks type. Appearance was exactly similar. Accidentally, I thought that this is the namkeen, and I consumed it. Right? When it was in my mouth, it all made my mouth inside dry, and that was very irritating. It was bitter in taste, little bit of bitter in taste. When it was drying it, basically, that is dehydrating it. The one property of the base is it is dehydrating. It consumes water, it absorbs water. Right? The bases are bitter in taste. You're right. Soap is a base. You're right. Okay. Any other example that you have of the board base?
So baking soda is a base.
Baking soda is a base. Yes. Baking soda is a base. Yes, you're right. Have you ever seen baking soda?
Yes, sir.
Okay. It might be in your kitchen, right? Okay. It's bitter.
I have not tasted it
You have not
in.
tasted it. Okay. It may without an experimental observation. You're telling me it is bitter. It is a base. Anyways, it's a base. Then why do you use it in our food? You might have seen this in the kitchen, right? Then why do you use it in kitchen? Like in baking something or what? I think it is used for making the cakes also and something else. Why? Vedant will tell. Shilon Karen? Shilo.
So can you repeat your question?
My question is the baking soda is bitter in taste, right? Smriti Iyer
Yes, sir.
is telling that baking soda is a base, and I told you that bases are bitter in taste. So what is the use of that? Why do we use baking soda? Because it's bitter in taste, and why we are using it in food? What's the purpose of that?
Can I tell?
Yes, Vedant.
So it helps in fermentation.
Fermentation. For the fermentation, I think, and we need some fungus, yeast or something.
I think baking soda will also work.
Yeah. Okay. Can you tell me what do you cook in baking soda?
So I don't know much.
I'm coming.
My mother makes pancakes in that she puts baking soda so they become nice and fluffy.
Okay. It becomes fluffy with that, right?
Yeah.
Okay. If you don't use the baking soda, it will not become fluffy.
Yeah.
Okay. Good. Good point. Why it becomes fluffy with the baking soda? That is a chemistry now, because I'm linking your whole thing with your syllabus now. I'm directly coming to your syllabus book, what is written in the books, and all these things are written there, but in some different language. I'll come to that part, because you will understand the chemistry when you're dealing with when you've seen it in daily life, right? Yes, Smriti, yeah, Mavish, have you seen this baking soda? Why do you add it? Why it makes the cake fluffy?
It reacts with the acid,
we are
so
not
it gives.
we are not adding acid in our food.
No. Like sometimes baking soda are used in certain foods, so it gives in certain food there may be some kind of acid content, so it reacts with it. So
But cake does not contain any acid, right?
So it fills the cake with some air pockets or something.
Okay, now I will tell you now. I'll tell you now. What happens here? I'm sharing my screen now, right? What's the formula for the baking soda, baking powder? NaHCO3, right? Sodium bicarbonate. Upon heating, it forms carbon dioxide plus Na2CO3 plus water. The carbon dioxide escapes. Now understand. Suppose this is my cake duff. Cake duff. And the carbon dioxide is produced inside. When it comes out, it'll make its path and making some pores and pipes. Some capillaries will be formed, and that will make it fluffy. When the carbon dioxide comes out, that will come out with some force, making some path inside, making some capillaries inside the food, and that will make it fluffy. Am I clear? Getting me? I stopped sharing.
Yes, sir.
This is the purpose of adding the base. That's sodium carbonate. Okay. Now I'll come to the word acid. I'll start from your book content now. Basically, in this discussion, right, for the last 20 minutes, I have been discussing with you from your daily applications, and now your learning will be very, very fast. Now you know what is acid, what is the base. Practically, this acid has been derived from a Latin word acidus. Acidus means sour in taste, sour to taste, right? Anything that we taste and it is sour, that must contain some acid. For example, all citrus fruit we have, they contain citric acid. Lemon contains ascorbic acid. Vinegar contains acetic acid, right? They all are acids which are sour in taste. Now I'll discuss, write down general characteristics of acids. General characteristics of acids. Number one, taste. They are sour. Number two, action on litmus paper. Action on litmus paper. We have a two different type of the colored paper. We call them litmus paper in our chemistry lab. Acid turn blue, litmus red. Acid turn blue, litmus red.
So you're not sharing your screen, so
No, I'm not sharing. Oh, I written this thing only. Wait. It is sour in taste, number one. Acidus means which is sour to taste. Number two, action on litmus paper. Acid turn blue, litmus red. Acid turn blue, litmus red. Acid turn blue, litmus red. Right? Note it down. Next, I'm talking about the physical state. What is the physical state? They are solid, liquid, or gas. For that, I'm saying
Liquid.
some acids are liquid, and some are solid also at room temperature. In the liquid state, we have an hydrochloric acid, we have sulfuric acid, we have a nitric acid, right? Carbonic acid. In the solid, we have an oxalic acid or boric acid. Boric acid and oxalic acid are solid. the white color powder like. Others are like HCl, sulfuric acid, nitric acid, carbonic acid. All these are. Have you noted down?
Yes, sir.
Now, when these are dissolved in water, suppose I dissolve this hydrochloric acid to water, I'm writing AQ. AQ means aqua. AQ means aqua. Aqua means water, dissolved in water. It gives ions, H positive and Cl negative ion. And when the ions are formed, they can conduct electricity. It means they conduct electricity in aqueous medium. Aqueous medium means when dissolved in water. Aqueous medium means when dissolved in water. They can conduct electricity. They produce these ions. We have a sulfuric acid. When dissolved in water, it gives ions. I'm talking about nitric acid. It gives H positive plus nitrogen. Understood? Yes or no? Are you understanding this? How I'm making an ions?
Yes, sir.
Are you unclear about this?
So maybe I think you can repeat it once.
I said they conduct electricity in aqueous medium. Why they can conduct electricity in the aqueous medium? Aqueous medium is when dissolved in water. Aqueous means dissolved in water. They are producing these ions. And now in this beaker, if we have this cation and anion, means positive ions and the negative ions. And now I am passing the current. Negative terminal, positive terminal. Negative terminal is cathode and positive terminal is anode. These ions will move towards the oppositely charged electrodes. When the ions move, the charge moves. The flow of charge is called the current. Flow of charge is called as the current. But the charge is in the form of the ions. So I can say when the ions move, when the ions flow, they conduct electricity. They conduct electricity. Am I clear? Any doubt till now? Please respond, please. I can't see you.
So,
Right. Next property, they are corrosive in nature. If you touch acids, they can burn the skin or they can give some burning sensation. If they come in contact with the clothes, they will make a hole in it. They're corrosive in nature. Right? So we have some acids like HCl, hydrochloric acid, nitric acid, sulfuric acid. They're very, very strong acids. So they are not tasted. They are not tasted. We don't taste it. If we taste it, it will burn our skin. It will burn our tongue. So they are highly, highly corrosive. Right? They are so strong that they will react with the metals like this. If we can't store it in metallic container like this, if we have a zinc metal and we add here hydrochloric acid, it will react with it. ZnCl2 and hydrogen gas. Salt solution will be formed. Suppose I have a beaker of the zinc and now I fill it with hydrochloric acid. What will happen? The zinc will start dissolving. Zinc will start dissolving and form a salt. And from where the holes will be created. So we can't store any acid in the metal container. So all these acids are stored in either in the glass or in ceramic. The container made up of the ceramics. They are not stored in any metal. Right? Am I clear?
Yes, sir.
Now, I'm stopping sharing for some time. I'm asking you very simple questions now. Mavish, Vedant, Manasvi, turn on video. Yeah. Keep it on. Okay. My question is, have you ever seen at in your kitchen, at your home, the curd being stored in the copper vessel?
No.
Which type of container do you use for storing curd?
Plastic or steel?
Plastic, it can be plastic, it can be steel, it can be glass, it can be some earthen pot. Yes or no? But not the copper. Reason being, copper and the acid present in the curd is lactic acid, and that will form a copper salt, and that will give a bitter appearance, bitter in taste, right? So it react with metals. Shiloh Karen, you're coming for the first time today in my
Yes, sir.
class? Yeah. Are you getting me?
Yes, sir.
Right. So we don't store curd in any alloy or metal of the copper vessel. Reason, it will react with it, make some salt, copper salt, and that will make it bitter. Rather, that type of salt formed is very toxic in nature. It's a poison. It's a poison, right? Copper salt solution is a poison. If it's taken in large quantity in the body, that will be causing some problem in our body. So we don't store curd in any vessel made up of the copper. Am I clear, everyone? Manasvi?
Yes, sir.
All right. Prem, turn on video, please. Manasvi, you too.
So I already have asked permission for the technical difficulty.
Okay. And what about Prem? Right. Now, next write on classification of acids. Write on classification of acids. These acids are of two types. One is called as an organic acid, other is called as a mineral acid. When I say organic acid, they have been derived from plants, and mineral acid derived from minerals, some inorganic salts, rock salts. I'll give you some examples of organic acids. Organic acids. Number one, we have an example of acetic acid obtained from vinegar. Citric acid obtained from orange or lemon. Tartaric acid obtained from tamarind or grapes. Oxalic acid obtained from tomato or spinach. Lactic acid, it is present in the sour milk, like we have a curd. So all these are organic acids. We have a long list of such acids, which are organic acids. We have stearic acid obtained from fats, butyric acid from butter. So all these are plant or animal extract.
So what's the last one?
Butyric acid, Butyric. Butyric acid, butter. Oh, wait, please. Just a minute. Am I clear, anyone? Note it down.
One minute.
So done.
Done. And now I'll give you some example of the mineral acids. We have a hydrochloric acid, nitric acid. I'm writing just a formula. You can write it complete name along with it. You can you tell me what is this one? The last one that I have written here. The last one. This one.
So sulfuric acid.
Good. Sulfuric acid. And we have an H2SO3. Can anyone of you tell me what is this one now? Write down sulfurous acid. Sulfurous acid. This compound is called as a carbonic acid. Carbonic acid. H3PO4 is called phosphoric acid. It's called as a phosphoric acid. Understood? Till now, any doubt? Any doubt till now? Keep on responding. I stopped sharing for some time. Yes. Smriti Iyer, where are you? You're gone. Okay. Manasvi, any doubt till now?
Think
Anyone?
so. Good answer.
Prem, Vedant, any doubt till now?
No, sir.
No. Have you noted down everything, everyone?
Sir, I haven't noted down everything.
These are the important things that I'm writing on the screen that you must know,
Uh,
right?
Sir, actually, I have a fracture on my hand, so I'm not able to write properly.
Then write it in your mind. It must be properly
Yeah,
remembered, right? You can take the
yeah,
screenshot. I think you can take the screenshot,
yeah.
right? And remember it as such. You can't write, no problem. But when you write it here also. You can do it mentally. Now, we can classify the acid as strong and a weak acid. What do you mean by the word strong and weak? Strong acid, weak acid. Practically, what does it mean? I stopped sharing. Understand here. Uh, have you ever heard this type of language? This drink is strong drink. This is a not so strong drink. What does it mean? strong drink. Let it be some, I had some lemon water, right? And if we have a more amount of the lemon dissolved in water, it is very, very sour in taste. So we call it is strong. But if you have less amount of the less sour in taste, it means less amount of the lemon is dissolved in it. We call it as light. Yes or no? Yes or no?
Yes, sir.
Right.
Yes.
So basically, the acid which gives very much sour might be strong, which are less sour that might be weak. That may be the idea, right? But in chemistry, we have a different concept. Basically, we say strong acid is the one which dissociate completely into their ions. For example, if I say HCl, when dissolved in water, it gives H positive Cl negative ion. And I'm showing one single arrow. It undergo complete dissociation, means all the molecules are dissociated completely. If we have 100 molecules of the sulfuric acid, it will give you 100 H positive ions and 100 sulfate ions. Completely dissociated. Right? Understood? And the weak acid are those which do not undergo complete dissociation into its ions. For example, we have this acetic acid. This undergoes incomplete dissociation. I'm using a double arrow. This means it's a state of equilibrium. Equilibrium means rate of the forward process is equal to rate of the backward process. The speed at which it is dissociating, at the same speed, it is again, the ions are again combining back to give the reactant. It means it's very less fraction of the acetic acid is dissociated. We call this is a weak acid. Am I clear? Am I clear? Yes or no?
Yes, sir.
Right. Anyone clear? Okay. Now, I'm talking about the basicity. Basicity. Basicity means number of the protons given by an acid in aqueous medium. Number of the protons given by an acid in aqueous medium. Suppose I say HCl, when dissolved in water, it is giving one proton. So we call this is a monobasic acid, and its basicity is equal to 1. Basicity is equal to 1. Basicity means how many H positive ions, how many protons are furnished by an acid in the aqueous medium. In the aqueous medium, how many H positive ions are given by an acid? That is called as its basicity. Am I clear? Everybody clear? Should I go ahead? You're not responding. Are you there? Everyone,
Yes, sir.
keep on responding yes, no, question, something. You sit so mute. Where is Prem Jaraman? Only the background scenery I'm teaching. Prem, are you there? Okay. Shilo? Shilo Karen, are you there?
Yes, sir.
Okay. Turn on video, please.
So I'm having some network issues, sir.
Okay. Are you using a mobile data?
No, sir.
Wi-Fi?
Yes, sir.
There shouldn't be any doubt, any problem then. Anyways, I'm sharing my screen. Now, this is a sulfuric acid. When it is dissolved in water, it can give 2H positive ions and 1 sulfate ion. We call this is a dibasic acid, or I can say its basicity is equal to 2. Its basicity is equal to 2. Phosphoric acid can give 3H positive ions and 1 phosphate ion. This is a tribasic acid. Basicity is equal to 3. Basicity is equal to 3. Should go ahead. Understood? Yes or no? Now, next write on chemical properties of acids. Chemical properties of acids. Number one property, metals plus acid, it gives salt and hydrogen gas. For example, I have magnesium hydrochloric acid. It'll give you magnesium chloride and hydrogen gas. Or iron plus sulfuric acid gives salt and hydrogen gas. Right? Only reactive metals like magnesium, iron, zinc, they react with the sulfuric acid and form salt and hydrogen. Understood? Any doubt till now?
No,
Noted
sir.
down? Okay. But less reactive element, less reactive metal do not react. We call reactivity series. Understand here, a reactivity series. Potassium, highly reactive. And I'm writing in a decreasing order of the reactivity. As I'm going down, the reactivity goes on decreasing. This potassium reacts explosively with water, sorry, with acids. These elements less vigorously. They react, but less vigorously. These elements react with dilute acids, right? And the elements which are below the hydrogen, they do not react. Copper, mercury, platinum, gold, they do not react. They do not react. Note it down. Understood? Till now, any
Yes, sir.
doubt? Right.
Yes, sir.
So this hydrogen gas will be liberated like zinc plus HCl. It'll form salt and hydrogen gas. And hydrogen gas is a combustible gas. It'll combine with oxygen and give a pop sound. It means this is a confirmatory test that this is an acid. With a metal, if something is giving out the hydrogen with a pop sound, it means that is an acid. It's a confirmatory test. Am I clear? Now, a reaction with next point. Reaction with metal carbonate and metal hydrogen carbonate. Metal hydrogen carbonate. Metal carbonate is Na2CO3, right? Like sodium carbonate. With acid, it will form here sodium chloride H2O plus CO2. Metal bicarbonate also will be reacting the similar way. Suppose I say calcium bicarbonate. HCO3 is a bicarbonate. Would form HCl, it forms CaCl2 plus water plus 2 moles of the carbon dioxide. They produce the water and carbon dioxide. Understood? Understood? Yes or no? Now, test for carbon dioxide gas. The carbon dioxide that is produced in this reaction will confirm that it is carbon dioxide. What is the test for that? We have a lime water test. Lime water is a calcium hydroxide. With carbon dioxide, it forms here calcium carbonate plus H2O. This will give you white color precipitate. This white color precipitate, white color turbidity, white color cloudiness indicates that it is a carbon dioxide, right? Understood? But if the carbon dioxide is in excess, then the calcium carbonate with excess of the carbon dioxide in the presence of the water will again give bicarbonate, and this is soluble in water. It means the precipitate produced in the first step will be dissolved in the excess of the carbon dioxide. Am I clear? Yes or no?
So,
Now, next write down reaction with metal oxides. Like we have a copper oxide with acid like HCl. It'll give you CuCl2 plus H2O. That's just balancing it. Or zinc oxide with H2SO4, it'll give you zinc sulfate plus water. Means salt plus water. Noted down? Understood? You don't talk. What happened? I stopped sharing. Till any doubt, Joe Daniel? Mavish?
No,
No. Vedant?
No doubt, sir.
Sheikh?
no doubt, sir.
No. Okay. Next, write down neutralization reaction. I'm stopping sharing. Can you tell me what do you mean by the word neutralization?
so when acid react to the base to form salt plus water.
Okay, you're telling me very technical terms, right? It means whenever we add acid to a base, the acidity of the acid will disappear, or the basicity of the base will decrease. The property of the acid base will be neutralized. It means acid property and basic property will no longer be available. It will no more be available with the salt solution. Suppose I say acid and I'm adding here a base. Can you complete the reaction? Can you complete the reaction here? You just do it one thing. H positive, Cl negative ion. Na positive and OH negative ion. What you do is you just exchange the partners. Now make an NaCl from here. It will form here an NaCl plus water. NaCl plus water. It is salt plus water. So acid property will disappear. Basic property will disappear. Such type of reaction in which acid neutralizes the base or the base neutralizes the acid is called as a neutralization reaction. Is called as a neutralization reaction. Now, let us see some applications of the acids and bases. Acids here. Sorry, application of neutralization. Write down. Application of neutralization.
Can you repeat? Applications?
Yeah. Application of neutralization reaction. Application of neutralization reaction. Number one. See, if a person has acidity in the stomach, what do you mean by that? Can you tell me? What is the meaning of the word acidity in the stomach? Have you ever observed this, Vedant?
Yes, sir.
Okay. What happens during that problem?
Sir, burning that feeling in the stomach.
Burning in the esophagus. Burning
Yes,
sensation in the
and
esophagus. This region part, right? In the stomach
yeah,
also, but here in this chest region
mostly in
also.
the esophagus.
Yeah, mostly in the esophagus. So what did doctor give to the patient?
So he gives
Something,
a
some
medicine that
tablet
is like a base. Yeah.
bases, yeah. So
Or a
base
syrup that is like pink in color. I don't know what's the name, I forgot.
Gelusil,
Yeah.
Gelusil, the pink color, right? Okay. They
Yeah.
contain bases, right? So stomach inside the stomach, there is the excess of the acid now. That is giving some problem now, right? Now when we add base to it, it gets neutralized. The problem disappear, right? Now, if the soil, okay, if some bees or ants give a bite on your skin, then what should you do? Whenever bees give a bite on your head, on your hand, or somewhere, anywhere, it gives a pain, right? So, my question is, how can we reduce the pain? See, the bees or ants in the saliva, there is a acid known as a formic acid. So, that acid should be neutralized immediately. Can you can you tell me how can you neutralize that acid? What should we do? We should add some base to it, right?
Yes, sir.
We should wash it with the soap. Soap is a base, yes or no? And formic acid is an acid. They will neutralize each other and the pain will be reduced. Right? Now, I'll give you in our lab how do we neutralize? In a lab, how do we neutralize? We have a beaker which contains some base. And now what we do is we take up a stand and here we have a burette. Burette is long tube and here we have an acid. Drop by drop, the acid will come in and will neutralize it. When the equal amount of the acid will be added to the base, the neutralization will take place. But how do we know that after this particular drop, it is now completely neutralized? Can you tell me? So what we do, we are adding some indicator here. Indicator I'm using here, phenolphthalein. This is pink in color in the base, and it's a colorless in acidic medium. So what is now here, when we add just one drop of the indicator in the base, that will turn to pink. Now we are adding acid drop by drop, and after some time what we will find that it has become colorless. When it becomes colorless, it means the neutralization process is complete. This neutralization process is complete. Am I clear? Yes. Any doubt till now? Any doubt till now? No doubt. Okay. Wait. I'm stopping sharing for some time. Let me open a file of assignment. Okay, before I go ahead, do you have any doubt till now? Mavish? Vedant?
No, sir.
No,
No.
sir.
Okay, so here is the first exercise that we will do. Here we have fill in the blanks. 1 to 10. Read them, and whatever you know, you make an answer, right? 1 to 10. Okay, I'll be coming back in just in 2 minutes. By the time you solve all this 1 to 10, right? I'll be back. Yes, hello everyone. Can you hear me? Hello, can all of you hear me? Yes, Joe Daniel. Okay, have you done these questions? Have you done these questions? Yes or no?
Yes, sir.
All right. I'm sharing my screen and I'll be discussing this assignment with you. Okay. Binary acid contain dash atom. What do you mean by the word binary acid? Which contain two hydrogen atom. Right on here, two hydrogen atom. Oxy acid contain oxygen atoms in addition to the hydrogen atom. Right on here, oxygen atoms. What does it mean? Suppose I say I have a sulfuric acid. The sulfuric acid contain hydrogen bonded to oxygen. So that is called as a oxy acid or phosphoric acid. This is known as a phosphoric acid. Hydrogen is bonded to oxygen. Such type of acids are called oxy acids. Note it down. Am I clear? Once you have noted down, let me know. Getting me? Should I go ahead? Hello. You don't respond. Vedant, can you hear me? Yeah. So
Yes, sir, I can hear you.
see, when I share my screen, I can't see your faces, right? So please speak out. Okay, I'm not able to share my screen. Students, I'll be joining again, right? Don't leave. I'll be joining again. Yes, I'm back now. Everyone, please turn on a video, please. Joe Daniel. Chilo, Manasvi.
Yes, sir.
Yeah. I'm sharing my screen now. An acid that contains more than one acidic hydrogen is called as a what? Which contain more than one acidic hydrogen. They are called as a polyprotic acid. Write down here polyprotic acid. Polyprotic acid, which gives only one H positive ions in the aqueous medium, that is called as a monobasic acid. Monobasic acid. Polyprotic acid or polybasic acid? Which contains more than one acidic hydrogen is called as a polybasic acid. Am I clear?
Yes.
Now, when an acid reacts to the metal, dash gas is evolved and corresponding dash is formed. What is that? Can you fill that? I'm waiting for a response. Yeah. When an acid react with a metal, dash gas is evolved and corresponding dash is formed. What is the which gas is produced?
Hydrogen gas.
Hydrogen gas, H2 gas, and corresponding what?
H2.
Corresponding salt is formed. Right? Acid plus water gives what? Salt plus hydrogen. Okay, now fifth question. When an acid reacts with a metal carbonate or metal hydrogen carbonate, it gives corresponding salt and what? Dash gas and dash what? Metal acid reacted metal carbonate. See, I have given here reaction. This one, metal carbonate with HCl. It produces salt plus water plus carbon dioxide. It means the answer should be water and carbon dioxide gas and water. Am I clear? Everyone? No doubt till now? Okay,
No, sir.
dash the fixed number of water molecule chemical attached to each formula unit of salt in the crystalline solid. Water in the this is water is a fixed number of water molecules. Write down water of hydration. Note it down, then I'll explain here. Water of hydration. What does it mean? Water of hydration. See, if I say I have a salt of copper sulfate. This salt is white in color. We call this is a anhydrous salt. And now we add water to it. It forms a copper sulfate dot 5 water molecule. This becomes blue in color and we call this is a hydrated salt. We call this is a hydrated salt, and these five water molecule, these are called as a water of hydration. So all salt is surrounded by fixed number of water molecules, and these are called as a water of hydration. Note it down. Once you're done, let me know. Am I clear? Hello? Should I go ahead? Next question.
Yes, sir.
Eno contain base and is alkaline in nature. Do you know what is eno? Who will tell me? Eno. Eno
Sir, it's a that is used for acidity to
yeah,
neutralize the.
good. So if the stomach has acidity, means more H positive and more acid, to neutralize it, we add here base. Base means here eno. And it is alkaline in nature, means it can give OH ions in the aqueous medium. Okay. Anhydrous common sodium carbonate is commonly known as dash soda. Sodium carbonate is called a soda. Na2CO3. Acid soda acid fire extinguisher contain a solution of sodium hydrogen carbonate and carbon dioxide. All the alkali are bases, but all the bases are not alkali. Alkali means those bases which can give OH ions, but all the basic substances are not able to give the OH ions. Suppose I say copper oxide, that is basic in nature. Ammonia is basic in nature, but they do not give any OH ions in the aqueous medium. Right? Alkali react with ammonium salt to produce corresponding salt, water, and let us see. Alkali means let it be sodium hydroxide. With ammonium salt, let it be ammonium chloride. They will give salt, means NaCl will be formed, water, and evolve what? Ammonium hydroxide. Ammonium hydroxide will dissociate to give ammonia. It means they will produce ammonia. Understood? Yes or no? Zinc hydroxide is a diacidic base. Diacidic base. They can give two OH, so these are diacidic base. Note it down. Yes, Vedant, getting this? Shake.
Yes, sir.
Right.
Yes, sir.
Okay, everyone. If you find difficulty, let me know, right? We can discuss it. Okay. You have to write true or false. Acidic nature of a substance is due to the formation of H positive ions in the solution. True or false?
True.
True. A base reacts to the metal along with the evolution of the hydrogen gas is formed, which has a positive ion and composed of metal and oxygen. When a base reacts with a metal along with the evolution, I have not discussed base yet, right? Leave it. Okay, mixing concentrated acid and base is what is highly endothermic process. Yes or no? Endothermic means in which heat is absorbed. When we mix the acid and a base, the heat energy will be absorbed. Yes or no?
Yes,
Suppose,
sir.
no. See, suppose we have a strong acid like HCl and a strong base. It forms NaCl plus water. Plus large amount of heat is liberated. So I can say the reaction is exothermic in nature. It is not endothermic. So this is false statement. Understood? Yes or no? Acid and a base neutralize each other to form salt and water. Yes or no? True or false? Very simple question I'm asking you. -3.
Yes,
Vedant.
sir.
Yeah, the statement is correct or wrong? True or false? Acid and a base neutralize each other and form corresponding salt.
So true.
True. The color of the caustic soda is NaOH. Turn pink when phenolphthalein is added to it. True or false?
So true, sir.
True. Right now I told you that in the basic medium phenolphthalein gives pink color. So the statement is true. Hydrogen chloride gas turns blue litmus red. Yes or no? Hydrogen chloride gas turn the blue litmus red. Yes or no?
False.
Acid turn the blue litmus red. The statement is correct. Base turn the red litmus blue. Right. The statement is correct. Sodium hydrogen carbonate is used as a fire extinguisher. Yes or no?
True.
Yeah, because they can give carbon dioxide. Washing soda on heating gives sodium oxide and carbon dioxide. What is washing soda technically? Na2CO3. Upon heating, that will give you now sodium oxide and carbon dioxide. The statement is correct. Next, 10th question, please. Bleaching powder. Bleaching powder is CaOCl2. Is used for disinfecting drinking water. Yes or no? True or false? Bleaching powder is used for disinfecting drinking water.
False.
True. It is used
So
for,
could you explain it?
see, drinking water to, if it is disinfecting, it will give you some basic solution. Whenever it is dissolved in water, it will give you calcium hydroxide and HCl. So this acid and the base will be they'll be killing the germs in the water or microorganisms in the water. Okay, sodium hydrogen carbonate is alkaline in nature. Does it give the OH ions in the solution? When we add a sodium hydrogen carbonate in water, let us see. It is a sodium hydrogen carbonate, NaHCO3 plus water. It will form here sodium hydroxide plus CO2 plus H2O. So the solution is basic, or I can say it is alkaline in nature. So sodium hydrocarbonate is alkaline in nature, yes or no? Yes, true.
True.
Okay, now next question. There are a variety of the strengths when you study acid and bases.
True.
True, good. An aqueous solution is the one which has a completely dissolved water.
True.
Which is completely dissolved water, right? True. Okay. Column 2 contains nature of the gas acid and the base mentioned in the column 1. Match them correctly. Hydrochloric acid is a strong acid, yes or no?
Yes.
HCN is a weak acid. This is also correct. Sodium hydroxide is a strong base, so it should be connected to the S part. And ammonium hydroxide is a weak base, so it is the R part. Am I clear?
Yes, sir.
Yes, sir.
We have to match them. It's a potassium nitrate, silver nitrate, magnesium chloride, ammonium carbonate. Where are they used?
The first one is the last one, nitric acid, potassium hydroxide.
Good.
The B1 is the first one, nitric acid, silver hydroxide.
Good. Hmm.
The C1 is the second one, hydrochloric acid, magnesium hydroxide.
Very good.
And the last one is R.
Harvard. Anyone having any doubt, ask me now. Understood? Chalo. Question number 1. Write the name of the product obtained when the zinc metal pieces are dropped in sodium hydroxide. Base I had not told you. Leave it. Second part you can do. Write a chemical equation for the hydrochloric acid of the marble chips. What is the marble chips technically? Chemically, what is marble chips? Calcium carbonate. And now it is HCl. This will give you now calcium chloride plus water molecule. Understood? Anyone having any doubt here? Now, next question now.
No, sir.
Come to number 6 question. With the help of the equation, show that metal carbonate liberate carbon dioxide on reaction with a dilute acid. So show it with the reaction. Sodium metal carbonate. Sodium carbonate, let it be Na2CO3. With an acid, it will produce here sodium chloride plus H2O plus CO2. That's it. Note it down. Okay. Why does dry HCl does not change the color of the dry litmus paper? Only the aqueous medium it does, right? When dissolved in water, it does. But in the dry HCl, does not change the color of the dry litmus paper. Why? Because this HCl, when it is dry, does not dissociate. This HCl dissociate in the aqueous medium, and now it can change the color of the litmus. So in the dry, it does not give ions. Write down, in the dry HCl, it does not give ions.
So can you repeat again?
In dry HCl, it does not dissociate to give ions. So it does not change the color of the litmus. It does not change the color of the litmus. Understood? Everyone? Now, how do we identify acids? How do we identify acids? So to identify an acid, we have number one, taste test, sour in taste. Number two, whenever any acid is treated with a metal, it forms salt and hydrogen gas. It forms salt and hydrogen gas. It forms salt and hydrogen gas. Right? So this hydrogen gas will burn the pop sound. It burn with pop sound. And this is how we can test an acid. Write it down. Once you're done, let me know. Done. Note it down, everyone. Yes, Jordaniel, Avish, Vedant, all of you turned your videos. Do you have any doubt, Sheikh,
No, sir, no.
Avish?
No, sir.
Okay, understood this much, whatever we had discussed till now? Vedant?
Yes, sir. Understood.
Okay, so this much you revise and next we'll continue ahead, right? Okay then, I'm ending session now. See you next week at the same time. No, not next
Thank
week,
you,
after,
sir.
after 15 days we have. Okay,
And sir, can you see about the question 4
which question
of
for?
the test? So the three options are correct, but they have only given one
Uh,
correct.
can you read out the question?
So it was about the student added dilute HCl to a test tube containing zinc granules and made the following
Yeah,
observations.
yeah, that's again I told you. It's all A, B, C are correct.
Yes,
All the three are
so will
correct.
we get marks for the question? Because I got it wrong.
Okay, that I'll talk to the checking team, right?
Yeah.
Okay then.